everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equations. So let's get going. Problem. Form partial differential equation from z equal to f of ax plus by plus phi of cx plus dy by eliminating the arbitrary functions f and phi. We are given a relation. We are asked to form a partial differential equation by eliminating f and phi, which are arbitrary functions. So let's see. Given z equal to f of ax plus by plus phi of cx plus dy, consider it as equation number 1. Now let's partially differentiate it with respect to x. Partially differentiating 1 with respect to x. Just apply dou by dou x on both sides of 1. In order to avoid mistakes, we'll just take dou by dou x on both sides of the equation, or you can do directly if you are good at finding partial derivative. This gives us dou z by dou x equal to partial derivative of f of ax plus by is f dash of ax plus by into inner derivative dou by dou x of ax plus by plus partial derivative of phi of cx plus dy is phi dash of cx plus dy into inner derivative dou by dou x of cx plus dy. Since we have a notation dou z by dou x equal to p, let's replace the LHS part by p. We'll get p equal to f dash of ax plus by into a times partial derivative of x with respect to x is 1 plus partial derivative of by with respect to x is 0 plus phi dash of cx plus dy into partial derivative of x with respect to x is 1 plus partial derivative of dy with respect to x is 0. Since we are partially differentiating with respect to x, so we'll treat y as constant here, okay? Fine. Now this gives us p equal to a into 1 a plus 0 a f dash. That is af dash of ax plus by plus c into 1 c plus 0 c into phi dash. Consider as equation number 2. Now let's partially differentiate 1 with respect to y. Partially differentiating 1 with respect to y. Just apply dou by dou y on both sides of 1. Right. This gives us dou z by dou y equal to, here we are partially differentiating with respect to y, so treat x as constant. Partial derivative of f with respect to y is f dash of ax plus by into inner derivative dou by dou y of ax plus by plus partial derivative of phi of cx plus dy with respect to y is phi dash of cx plus dy into inner derivative dou by dou y of cx plus dy. Since we have a notation dou z by dou y equal to q, so we'll replace it by q. You'll get q equal to f dash of ax plus by into partial derivative of ax with respect to y is 0 plus b into partial derivative of y with respect to y is 1 plus phi dash of cx plus dy into partial derivative of cx with respect to y is 0 plus d into partial derivative of y with respect to y is 1. And this gives us q equal to b into 1 b plus 0 is b into f dash is f dash of ax plus by plus d into 1 d into 0 d into phi dash is d phi dash of cx plus dy. Consider as equation number 3. See, equation 2 involves P, equation 3 involves Q, right? Now let's find the equation involving R. We know that R is nothing but dou square z by dou x square, right? We can write this as dou by dou x of dou z by dou x. We know that dou z by dou x can be replaced by the notation P, so you'll get dou by dou x of P, which gives us dou P by dou x, right? So partial derivative of P with respect to x gives R. So now we need to find equation involving R. For that, we'll use equation involving P, that is equation 2, and we'll partially differentiate it with respect to x, so that you'll get the equation involving R. So let's partially differentiate 2 with respect to x. Here you can write dou z by dou x instead of P, because P is nothing but dou z by dou x, right? You can write either P or dou z by dou x. Okay, fine. Now let's find. Now let's partially differentiate 2 with respect to x. Partially differentiating 2 with respect to x. Just apply dou by dou x on both sides of 2. This gives us dou square z by dou x square equal to a into partial derivative of f dash of ax plus by is f double dash of ax plus by into inner derivative dou by dou x of ax plus by. See, here we are partially differentiating with respect to x, so we'll treat y as constant, plus c constant into partial derivative of phi dash with respect to x is phi double dash of cx plus dy into inner derivative dou by dou x of cx plus dy, right? Since dou square z by dou x square can be replaced by r, that is notation r, so we'll replace it by r. You'll get r equal to a into f double dash of ax plus by into partial derivative of a into partial derivative of x with respect to x is 1 plus partial derivative of by with respect to x is 0 plus c into phi double dash of cx plus dy into c times partial derivative of x with respect to x is 1 plus partial derivative of dy with respect to x is 0. This gives us r equal to a into 1 a plus 0 a into a square into f double dash of x plus by plus c into 1 c plus 0 c into c square into phi double dash of cx plus dy. Consider as equation number 4. Now let's find equation involving t. We know that t is nothing but dou square z by dou y square, or we can write this as dou by dou y of dou z by dou y. We know that dou z by dou y can be replaced by the notation q, so that you'll get dou q by dou y. So in order to find equation involving t, pick equation involving q. So this is the equation involving q. Now by partially differentiating it with respect to y, we'll get the equation involving t. Okay. Instead of q, we can write dou z by dou y, since dou z by dou y is nothing but q. Okay. Now let's partially differentiate 3 with respect to y. Just apply dou by dou y on both sides of 3. Instead of taking q, I'll take dou z by dou y equal to dou by dou y of RHS part of 3. That is b into f dash of ax plus by plus d into phi dash of cx plus dy. This gives us dou square z by dou y square equal to b into, here we are partially differentiating with respect to y, so we'll treat x as constant. Partial derivative of f dash with respect to y is f double dash of ax plus by into inner derivative dou by dou y of ax plus by plus d into partial derivative of phi dash of cx plus dy is phi double dash of cx plus dy into inner derivative dou by dou y of cx plus dy. This gives us, since we know that dou square z by dou y square can be replaced by t, you'll get t equal to b into f double dash of ax plus by into partial derivative of ax with respect to y is 0 plus b times partial derivative of y with respect to y is 1 plus d into phi double dash, it's d, okay, d into phi double dash of cx plus dy into partial derivative of cx with respect to y is 0 plus d into partial derivative of y with respect to y is 1, and this gives us t equal to b into 1 b plus 0 b into b square, you'll get b square f double dash plus d into 1 d plus 0 d into d square into f double dash. Consider as equation number 5. Since dou square z by dou y square can be replaced by t, so we got t here, okay? Fine. Now we got equations involving r and t. If you notice here, you're having f double dash plus phi double dash, f double dash plus phi double dash. Let's now find the equation involving s also. Okay, let's see. We know that s is nothing but dou square z by dou x dou y. We can write this as dou by dou x of dou z by dou y or dou by dou y of dou z by dou x. Since dou z by dou y is nothing but q, we'll get dou x, partial derivative of q with respect to x. Here dou z by dou x is nothing but p. You get dou p by dou y. Either you can pick equation involving q or equation involving p. So if you pick equation involving q, just partially differentiate it with respect to x so that you'll get equation involving s. And if you want to find equation involving s using equation involving p, just pick this equation and partially differentiate it with respect to y so that you'll get equation involving s. You can take any of these two. Now I'm going to try for q. Okay, I'll take equation 3. Q is nothing but dou z by dou y, right? Fine. Now let's partially differentiate 3 with respect to x. Just apply dou by dou x on both sides of 3. This gives us dou square z by dou x dou y equal to b into partial derivative of f dash of ax plus by is f double dash of ax plus by into inner derivative dou by dou x of ax plus by plus d into partial derivative of phi dash with respect to x is phi double dash of cx plus dy into inner derivative dou by dou x of cx plus dy. Here we are partially differentiating with respect to x, so we'll treat y as constant. Since dou square z by dou x dou y equal to s, just replace it by s. We'll get s equal to b into f double dash of ax plus by into a into partial derivative of x with respect to x is 1 plus partial derivative of by with respect to x is 0 plus d into phi double dash of cx plus dy into partial derivative of x with respect to x is 1 plus partial derivative of dy with respect to x is 0. This gives us s equal to a into 1 a plus 0 a into b a b, f double dash of ax plus by plus c into 1 c plus 0 c into d c d, phi double dash of cx plus dy. Now consider it as equation number 6. Okay, fine. Now observe all the equations we have and let's see how to find partial differential equation. Now observe equation 4, 5 and 6. See, all these are in same pattern, f double dash phi double dash, f double dash phi double dash, f double dash phi double dash, that is plus. Okay, so let's find partial differential equation using determinant. Okay, now R T S quotient of f double dash a square, quotient of f double dash b square, quotient of f double dash ab, quotient of phi double dash c square, quotient of phi double dash d square, quotient of phi double dash ct equal to 0. Okay, this gives us r into b square d square ab cd minus a square into td square scd, right, plus c square into tb square sab equal to 0. Just simplify it. You'll get r times b square cd minus d square ab minus a square times tcd minus sd square plus c square times tab minus sb square equal to 0. We'll get r b square cd minus r d square ab minus a square tcd minus into minus plus a square sd square plus c square tab minus c square sb square equal to 0. Right? Fine. Now take RB common from these two terms. Okay, I think you can take R, 1B and 1D common from these two terms. We'll have R into 1B C minus 1D and this A, right? Fine. Now observe the terms involving T. So here you have T, A, C common in these two terms, right? So let's take minus T, C, A common. Then you'll get 1A, D plus Okay, minus here you have 1c and b. I'm just trying to write in just a pattern form. So here you have BC minus AD, right? So here also we can write in BC minus AD. Let's take plus itself, then we can take in same pattern. I'm trying to write in same pattern, okay? Don't get confused. So here you have plus B, 1B, 1C minus 1A and D. Okay, just took T, 1A, C common, 1C, T and A. Okay, then you'll get BC minus AD. Okay, fine. Now coming to this term, that is term involving S. Just take S common, easy. Better, let's take minus S common from these two terms. Then we get minus S times B square C square minus A square D square. Okay, equal to 0. Easy, right? Fine. Now I'm taking this term to RHS for my convenience. You can write dA as AD. Okay, plus T times BC minus AD into AC equal to S times B square C square minus A square D square. This gives us, now take BC minus AD common here. You'll get R BD plus T AC equal to S times, this is of A square minus B square form, right? You can write this as A plus B into A minus B. So by dividing both sides of the equation with BC minus AD, this BC minus AD gets cancelled and this results to RBD plus TAC equal to S times BC plus AD. Okay, fine. Now let's bring this term to LHS. You can write BDR plus ACT minus, you can just write this as ADE plus BC into S equal to 0, or you can write this as BDR minus AD plus BC into S plus AC into T equal to 0, which is a required partial differential equation. Or you can write this as BDR is nothing but dou square Z by dou X square minus of AD plus BC into S is nothing but dou square Z by dou X dou Y plus AC into dou square Z by dou Y square equal to 0, which is the required partial differential equation. This completes the problem. Either you can write like this or like this. Okay. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.